Okay, our first lesson on differentiation. Now, my best advice to you on differentiation is to really put a lot of effort into it from the start, because it is an extremely long part of the course. It's 2 chapters, but it's 2 long chapters. Okay, it's guaranteed to come up in the paper every single year. Okay, we're going to be spending a lot of time on it next year again, so really make sure you don't get turned off it. Make sure you get the basic rules from day one. Okay, so differentiation is the rate of change of one quantity with respect to another. Okay, so an example of rates of change would be speed. So speed is the rate at which distance changes with respect to time. Slope is the rate at which y changes with respect to x. Okay, so they're just 2 examples of rates of change. Okay, there are infinitely many examples of rates of change. It could be the rate at which a swimming pool is filling with water. Okay, the rate at which a tank is emptying of water, or okay, there's infinitely many examples of rate of change. I want you to think of that from day one. If you see a question that says find the rate at, straight away that means differentiate. Okay, now we're not going to be worrying about that too much at the moment. We just want to practice the basic rules of how to differentiate first before we talk about applying it. Okay, but if we can just think about that rate of change, speed and slope, if they could be in the background now of our minds, it'd be great to have heard it once anyway already. Okay, so differentiation by rule. Okay, so if y is equal to x to the power of n, then, so dy dx, okay, so y becomes dy dx to show that it's been differentiated. Okay, then n is the power, so the power becomes n minus 1, and the power gets brought to the front. Okay, so the power n is brought to the front and reduced by 1. Then here in this one, this time a is just any number. So again, the power gets brought to the front, so na, and the power is reduced by 1, so n minus 1.